Fusion 6 includes the SetDomain, SetCanvas, and AutoDomain tools specifically to help artists optimize scenes to take advantage of domain of definition rendering. In this video, I will show you how to use these tools to vastly improve the render performance of an existing composition. To help illustrate my point, I will use a composition created for the 2008 Disney film, Tinker Bell. This particular scene contains 6 characters in total, each with many layers for diffuse color, specular color, shadows, translucence, and color adjustments. This makes it an ideal candidate for domain of definition optimization. I have loaded a copy of the original composition here, and the only changes I have made were to tidy up the position of the tools so that the organization of the composition would be clearer at a quick glance. Each of the vertical towers of tools contains the layers that combine to place a single fairy into the scene. There are a total of 768 tools in this composition, including 203 1920 by 1080 HD loaders. The composition was originally created in Fusion 5.2. The laptop I use to record these videos is a Dell Latitude E6500 with a 3.0 GHz Core 2 Duo and a 4 GB of RAM installed. By today's standards, that's hardly a powerhouse workstation. When I rendered this composition using the 64-bit version of Fusion 5.3, it took an average of 79.38 seconds to render a frame. I then loaded the exact same composition in the 64-bit version of Fusion 6.0, build 448, and without making any changes, the average time per frame render dropped to 55.35 seconds a frame, an improvement of 30% over the original. A 30% improvement is nothing to sneer at, but when the layers in the composition were modified to take advantage of domain of definition rendering, the average render time per frame dropped to 20.22 seconds per frame. That's an improvement of nearly 400%. Let me show you what I did to achieve that result. I have displayed the base diffuse layer for one of the fairy characters in the scene. You can see that this fairy was rendered as a post-multiplied image, so we know that pixels which are not fairy will be black with a 0 alpha channel. This image is rendered as an SGI sequence at 1920 by 1080. When I enable the DoD option in the Display View toolbar, we can see the domain of definition for this image covers the entire frame. But realistically, we only need to process in the frame the portion of the pixels which are fairy. So in this image sequence, if it was an OpenEXR, it's possible that some 3D renders would actually have included the domain of definition in the file's header. Since this is an SGI sequence, we're going to have to define it for ourselves. Now, one way to do this is to add a SetDomain tool, which we will find in the miscellaneous category of tools. The adjust mode can be used to modify the size of the existing domain of definition, but for this purpose we're going to switch the tool to set mode and replace the domain of definition with new values. Now we can drag the edges in the display to more closely match the actual space taken up by the character. Since the character moves throughout the shot, we would then have to animate the controls and ensure that she wasn't clipped. As you may recall, there are over 200 layers in this scene, so that could very quickly become tedious and time-consuming. Instead, we'll use the AutoDomain tool, which is also found in the miscellaneous category of tools. This tool attempts to automatically calculate the domain of definition by comparing the pixels in the image to the canvas color. The canvas color tells Fusion which color pixels outside the domain of definition are. Unsurprisingly, the default canvas color for images which do not define one is black with no alpha, as we can see here in the color inspector. Now that matches up nicely with post-multiplied images, such as this one. But what if the image is not post-multiplied with an alpha channel? For example, the shadow passes in this composition are rendered against black with a solid alpha channel. This works because the layer is simply going to be multiplied by the diffuse channel. But if we try to use AutoDomain, it will fail to produce a useful result. So we can use the SetCanvas Color tool to define a new canvas color for the image, and we'll find that tool in the Color category. In this case, we're going to define a black with solid alpha as our canvas color. And now the AutoDomain works. Now we don't really want to set the AutoDomain for every loader in the composition, because scanning the whole frame to determine the DoD takes time. Instead, we will use the second image input on the SetDomain tool, which will allow us to copy the domain of definition from one image sequence into another. That way, we only have to calculate the AutoDomain once for one layer, and then we just copy it to the rest of the layers that have the same bounds. Now in the end, it took me about 45 minutes to add 150 domain tools to this composition. When I was done, the render performance had increased by 400%. Now if you do this as you build the composition, the time it takes is pretty much negligible. In fact, this may be the first time I've ever increased the tool count in a composition by over 10% and made it faster in the process. In my opinion, that's time well spent.